back for another update from home. I have my coal stove going. Temperature outside is 45 degrees. So what I'm going to talk about here today is a recap of what happened with Melissa, and also some information on what could be upcoming for this winter for a pattern of the jet stream. First of all, again, what happened with Melissa, I feel it might have been a Cat 3 at landfall, possibly, but it was mostly a 1 and a 2. In spite of all the dramatic pictures they're showing, which who knows how many of them are real and how many of them are not, or AI generated pictures, or what's genuine, hard to say. But watching the videos, like I say, from St. Elizabeth area, I mean, the winds were strong, but nowhere near Category 5 strength, at least from what I saw. In contrast, great hurricanes of the past, the atmospheric pressure was measured from the ground level at the point of landfall, or at the point where the hurricane passed over. There were no Hurricane Hunter planes, no dropsons. Back in the past, when hurricanes hit, the measurements were taken up from what they actually saw, what they actually witnessed. And they're trying to compare this storm to the Labor Day hurricane of 1935, or that it was worse than Wilma in 2005, worse than Katrina. Was that really the case? I'm extremely doubtful that it was the case, truly. As far as I'm concerned, looking at the videos, I mean, I witnessed Gloria in Long Island in 1985. It came ashore as a Category 2 hurricane, and the eye didn't move right over where I was, but it came close enough, within 10 miles, and I don't really think, it seemed to me, this storm, for the most part, was no worse than what I witnessed with Gloria back in 1985. So, I know that people might say, well, you know, it was a 20-mile wide path of destruction, and I realize the storm was pretty compact in size, but I would think that the winds would have extended further out than just 20 miles wide. I mean, the eye was 15 miles wide in itself, and usually the worst part of the hurricane is, if it's moving northbound, is the left side, where the videos that I watched were on that side of the hurricane. It should have been the bad side of the hurricane. And to me, it looked no worse than Gloria was, that I witnessed. I mean, looking at what happened on the video. Gloria is now, or not Gloria, Melissa is now a thing of the past. Gloria definitely is a thing of the past. It was 4 decades ago. But what I'm going to go into in more detail here is, I do have the book 1938 Hurricane. It's called A Wind to Shake the World. Story of the 1938 hurricane that hit New England and Long Island, New York. And I've had this book for a long time. And the intro to the book talked about the person named Everett S. Allen. Had begun his first day as a reporter for the New Bedford Standard Times. Before that day was over, he and hundreds of thousands of others on the northeastern coast had experienced the worst natural disaster in American history, a hurricane that, in terms of death, destruction, and injury, surpassed both the San Francisco earthquake and the Great Chicago Fire. A Wind to Shake the World is the first comprehensive account of this disaster, based on diaries, letters, interviews, first-person recollections, and the files of newspapers and libraries. It relives that terrible day and its aftermath from a personal historical viewpoint. No one could have been prepared for the storm's ferocity, sweeping suddenly northward from Cape Hatteras, building tremendous momentum as it advanced. The hurricane raced over 600 miles in only 12 hours. Winds of 100 to 130 miles an hour and swiftly rising water of almost tidal wave proportions slammed into the shore from South Jersey to Boston, most severely from Long Island to Cape Cod. And it goes on. To the effects of the storm, winds well over 100 miles an hour, sustained when it came ashore. Severe flooding, severe damage. And the book goes into different areas that it hit, starting with Long Island, New York, and the impact that it had on New Jersey, New York City, and Long Island. Winds in New York City itself did reach 65 miles an hour sustained, even though they were probably like at least 60, 70 miles from the eye. And on the good side of the storm, the winds in New York City still reached 65. But this goes into what led up to this person's involvement with this storm. And then it goes into accounts. There was one person, for example, that drove from Times Square to the eastern end of Long Island in this storm, drove through it, and gives the account of what this person experienced as he drove into the storm as it approached. The debris that was flying through the air, the trees that were coming down. So this book goes into detail about this storm, and as far as I'm concerned, while I read in that book, it was worse than what happened in Jamaica. The storm was moving at 60 miles an hour, and it still did all that damage. This storm was hardly moving in comparison that we just had in Jamaica. So now Melissa is again history. It's out in the Atlantic. It's no longer a hurricane. It lost its hurricane status yesterday, although the National Weather Service said it held on till today. It lost it by yesterday afternoon. I looked at the images. So here, now I've been talking about the winter. What's going to happen this winter? I'm going to show you an illustration here out of this book, which was written before the global warming agenda took hold of the earth. I've had this book for a very long time. This goes into different jet stream patterns, different sea surface temperature patterns, and what they lead to for weather patterns over North America. I've already been touching on this a lot. They are claiming, as I stated in my last video, they're claiming that the sea surface temperatures in this area are much warmer than normal. And you can see this was a prevalent pattern during the 70s. At least the early 70s. This book was written in the middle 70s. The jet stream tended to take this path, bringing cold weather to the west, warm weather to the east. We did have some very mild winters in the early 70s in the eastern U.S. The western U.S., in contrast, had very cold winters. So you can see that they're claiming that water temperatures presently are warm in this area, but are they? Is this the pattern we're seeing the jet stream taking right now? Or is it closer to this pattern, where we have a ridge over North America with the jet stream coming down over the east like this? Which pattern to you looks like the pattern we're seeing right now? Is it this one, or is it this one? Well, I say resoundingly, it's this pattern. Definitely this pattern. So what does this pattern indicate? It indicates that the waters through here are colder than average. You would have to have colder than average waters through here to get this kind of jet stream pattern. With warmer, relatively warmer water through here, off California and off of Mexico, perhaps. However, there could be variations to this. If solar activity is high, that ridge could extend across most of North America, and the trough downstream would be over the North Atlantic instead, with most of North America mild. With less solar activity, the jet stream could come down like this, come up, come down like this, and go back up over the east, bringing a cold, stormy winter to the eastern U.S. Now with this pattern, this is what we saw back in 2013-14. We were in a solar max, so the trough downstream wasn't extended further than this and probably made it to the East Coast, which is why most of the U.S. that winter was cold, because you had that patch of warm water. The jet stream went south like this, but in the case of high solar activity, or we were in a solar max at that point, 2014, the trough was wider than it would have been otherwise, so the jet stream took a more eastward course and came up the East Coast instead, coming up through the Great Lakes. In a period of low solar activity, it would bend more like this, come up, come down. So you can see how this can be a variable situation, but right now, you look at the jet stream pattern, it matches this here right now, meaning that the waters through here, as I've been saying, are not warm right now. They cannot be warm because the jet stream is taking this path. And this is the weather pattern from the 60s. So with the solar activity going into decline, this is going to become more amplified. Jet stream is going to go up this way and then come down and perhaps come up like that. if this was like a period of higher solar activity, we would have the jet stream coming down, coming up, and staying up till it got out to the Atlantic, meaning most of the U.S. would have a mild winter. What we do know is, right now, this is the pattern we're getting most frequently. Meaning, again, there is a cool patch of water or cold up in this region right now, contrary to what they're trying to tell us. Because if the waters were really record warm in this region, as they're claiming, this is the pattern we should be getting. California should be getting raked with storm after storm. There should not be a ridge over the west right now at all with this pattern. Should not be getting ridging over the west coast or in the western U.S. And I've been talking about the MJO. Now, back in this point in time, they had not realized about the MJO. But this is a satellite image from 1973. This is May, early May. And notice all the convection and the intertropical convergence zone. This is what I'm talking about with the MJO. It's convection around the equator. The subtropical highs, you can pretty well pick out where they are, where the absence of clouds are, like in here, over northern Africa, the Pacific, over this region. And then, of course, where the jet stream is going, you can pick that out as well. That was back from 1973, and if we look at images today, one thing I do notice is that the intertropical convergence zone as a whole is a lot less active now than it was back then. There's a lot less clouds ringing the equator right now as a whole. What that means is overall there was a lot more convection back then than present times. And now what I'm talking about with the jet stream, there's some years where you get only this kind of configuration. You get this, you can get this, or you can even get this. During periods of high solar activity, you're going to see this more often. During periods of low solar activity or solar minimums, you're going to see that more often. You're going to see this more often in the summer where winds are weaker. You're going to see less zigzags in the winter when winds are stronger, but during solar minimums, even in the winter, you're going to get more patterns like this. In a pattern like this, it's very hard to get much snow because you need the jet stream to come up the eastern seaboard to get snow in the eastern U.S. more often. A pattern like this is too zonal. The low pressures are going to come in from the west. They're not going to have much moisture. You need a pattern more like this to get nor'easters. So this is how this book was written way before global warming started its agenda. This is another picture from 1973. This was taken in the end of July. Again, notice all the convection going on The intertropical convergence zone. It seems like a lot more than we see today overall. And notice the hurricane out in the Pacific there. Notice how perfectly shaped it is. Notice that it's not have the comet effect I've been talking about. Notice how it's surrounded by high pressure. It's a natural system. The eye is right in the center. Notice the jet stream pattern over the Pacific. And again, that reflects the warm water that was in here. You got the ridge because the waters here were warmer than average. You got a trough here, a ridge, and then a trough over here. A ridge out in the Atlantic, it looks like. The Azores Bermuda High is right in here. Because we had the trough in the east, the high and the Bermuda High was a little suppressed at this point down here more. But you can see the high reaches over into Western Europe, nosing its way into Portugal and Spain there. And then south of that you have Africa with all the convection. You have the waves coming off Africa, which were coming off where they usually come off, because they're trying to claim now that it's coming off further north than usual. But we look back in 1973, it seems like it was further north back then than now, a little bit. So I'm just sharing this interesting information. Again, this book was put out way before global warming. There's another picture of the Earth from the Apollo 10 mission in 1969. You can see the low pressure over the eastern U.S. And we can see the pattern that's similar to now, where I was showing you a little while ago with the trough over the eastern Pacific and a jet stream coming up like this over the west and coming down over the east. And that's the pattern I think we're going to see this winter. Due to the sea surface temperature situation here, there's a good chance we're going to see a similar pattern to this. So that's going to be it for this video. I hope you enjoyed this information I shared. I'll be back soon.